Welcome to my mathematics session today. Let me continue with Fourier series. I have been teaching problems in Fourier series for the past 3 classes. You are asked to get f of x in terms of cosine only in the interval 0 to pi. Then you extend this function on the other half minus pi to 0, and then find the Fourier coefficient of a0 and an, so that your f of x will be equal to a0 by 2 of 1 to infinity and an cos nx, and you have to find the value of a0 and an. Can you understand? By taking a0 is equal to 2 by pi, it must be taken like this, that is 1 by pi minus pi to plus pi, it is f of x dx, which must be equal to what? 2 by pi 0 to pi f of x dx. So what is that? And naturally what will be your an? An will be equal to your 1 by pi minus pi to plus pi, then f of x cos nx dx, and this will be equal to 2 by pi, it is 0 to pi f of x cos nx dx. So we have to find this a0 and an. So what is that we do? If f of x is defined somewhere here, and you extend it to, suppose that it is a line like this, you extend it to minus pi to plus pi, minus pi to 0 like this, and then integrate it over what? Minus pi to pi plus pi, and use the idea of this what? That is, it is a even function, and you take it as 2 by pi to integral of 0 to pi f of x n dx. Suppose you want the f of x in terms of sine alone, then the same way you extend it to minus pi to plus pi, minus pi to 0, and then you see that in the series, see what is your Fourier series? It is a0 by 2, a0 by 2, and it is 1 to infinity of an cos nx plus it is 1 to infinity of bn sin nx. So this is your Fourier series. But if you are asked to find the function f of x only in terms of sine, then you see that you extend it over minus pi to 0, and get the value of bn only, and this a0 and an need not be formed. You find the value of bn by using what? How will you do that? It is your bn will be equal to 1 by pi, it is minus pi to plus pi f of x sin nx dx. So this will be naturally 2 by pi 0 to pi f of x and sin nx. After finding this value, you substitute here, substitute here, this will be 0 and this will not come, they will not come here. So your f of x will be equal to this value. So this is how we do it. So in short, what I am telling you is that if you are asked to find, if your function is given f of x in 0 to pi, and you are asked to get the in terms of cosine only, then in the Fourier series find the value of a0 and an by extending it over to minus pi to 0, and find a0 is equal to, what is that you will find? a0 is equal to 2 by pi into 0 to pi f of x dx, and an will be equal to what? 1 by pi, that is 1 by pi into minus pi to f of pi plus pi of this, so that 2 by pi 0 to pi f of x cos nx dx. In case if you are asked to get this very same function in 0 to pi only in terms of sine, then in the Fourier series a0 will not come, an will not come, only you have to find the value of bn, and that bn is equal to what? 1 by pi minus pi to plus pi f of x sin nx dx, and this will be equal to 2 by pi 0 to pi f of x sine dx. Substitute these values here, you will get the sine series, and these two will not come. Can you understand? So the same thing that I am going to do here only. Now you are asked to find what is the problem. It is given here. You are given that here this x sine x. See, can you see this x sine x? See, this x sine x has to be got, or x sine has to be expressed in terms of cosine alone. That means what? It is defined in 0 to pi. See, here it is defined in series multiples of x will represent x. See, it is defined in the interval 0 to pi. So what is that you will do? You will extend the function to minus pi to 0. Now minus pi to 0, 0 to pi, and use the idea of what? That is, you call find the value of a naught and an. Substitute the values in the Fourier series, you will get the answer. So I will do this. So let us start doing this problem. Now, given, I write here, let, see what is that, how will you write this? That is a way to write, let f of x be equal to x sine x, and it is x lies between 0 to pi. 0 to pi. 2. See, I write here, to get f of x in terms of cosine. See, here it is asked, get in terms of cosine multiples. Then the Fourier series for f of x will be see, what is that? F of x is equal to, it is nothing but what? A naught by 2 plus sigma of 1 to infinity of an cosine x, where a naught is equal to, I write here, it is minus pi to plus pi f of x dx, which will be equal to 2, it's 1 by pi, 2 by pi, it is 0 to pi f of x dx. And similarly, what is that you will get? An will be equal to 2 by pi 0 to pi f of x cos nx dx. So you see that. Now I hope that you are clear in understanding what I teach in the class. So you see that this f of x series will be only this, because it will be only in terms of cosine. A naught is given like this, an is given like this. Now you get the value, you substitute the values in the place of f of x, do all integrations, and then finally arrive at the answer. Substitute in this f of x 1, substitute the values in 1, you will get the series. After then we will deduce this. This we will prove afterwards. Now let me start doing this. What is your a naught now? Now a naught is equal to, I will start doing this. It is 1 by pi, it is minus pi to, it is actually minus pi to plus pi, it is f of x dx. So this is equal to 1 by 2 by pi, I'll straight away write. It's 2 by pi, and it is 0 to pi x sine x dx. Now you see that this can be written as 2 by pi 0 to pi x. The sine x is d of minus cos x. See, what is d of minus cos x? Differential of cos x is minus sine x. So minus sine x, minus will make it as plus, and you must understand that divided by 1, that is understood. So you see that this is what you will get. So this is minus, and the minus will be sine. So this will be. So I have written. So you take this as your V1. So what is that you will get? Now Bernoulli's method, UV1. What is that? X minus cos x. Then minus, differentiate this u dash. U dash is here. See this one I will write here because you may commit a mistake here. So x, it is minus cos x. Then differentiate this x, it is 1. And what is the integration of cos x? Integration of cos x is minus. You have to integrate this. Differentiate this, whereas you have to integrate this cos x. Integration of cos x is minus sin x. So you will get it as what? It is minus sin, minus into minus will make it as sin x. And this must be raised to 0 to pi. And this 2 by pi is there. So this will be equal to your 2 by pi. And you will get this to be x cos x minus sin x raised to 0 to pi. That is 2 by pi. It is minus pi. Apply the upper limit. So it is cos pi. Apply the first limit, minus sin pi. Then this is 0. 0 into cos 0 minus sin 0. So this is 0. This is 0. Cos 0 may be 1. But 0 into anything is 0. Sin 0 is 0. This is 0. So you are left with what? So it is minus into minus c. This will become plus. So you will get this to be what? Minus. So it is, yes, this is minus c. It is minus 2 into cos pi minus 2 into cos pi is minus 1. Cos pi. So you get this to be what? It is equal to your 2. So what is that value that you are getting here? So A naught is equal to 2. So this is what we get for the first one. Let me go for the AN. Now what is my AN? I will rub off this so that you will understand better. So I will erase this. So AN will be what? Patiently you must do, otherwise you will not get the answer. You must have the high patience to do the problem. So you see that this is, again with an understanding, I will write here 0 to pi x sin x into cos nx. So into dx. So this will be equal to, I will write this as 1 by pi 0 to pi x 2 sin x cos nx into dx. Now you see that I will write something here, sine of a plus b minus sine of a minus b will be equal to what? This is sine a cos b plus cos a sin b minus sin a cos b plus cos a sin b. So you see that these two will go giving you what? 2 sin a cos b. Here's 2 sin b cos a. So you call this as your b. So this is like this. This is here. See, this is your b like this. This is your b. So you take this as your b and this is as your a. So what is that you will get here now? So this is equal to, using that formula, you will get this as, it is 0 to pi 2 sin a cos b. You can write, even you can use 2 sin a cos b, taking this as your this one. You can take, there is nothing wrong. You can take even this a and this as b. So this is 2 sin a cos b means what? Sine of a plus b plus sine of a minus b. I can write that also, no problem. Sine of c, I can write this as sine of a plus b plus sine of a minus b is equal to 2 sin A cos B. Because this is sin A cos B, this is sin A cos B, plus and minus will go off, giving you 2 sin A cos B. No, nothing wrong in that. So you take this as A and this as B. So what is that you will get here? 2 here sin of A 1 plus n of x plus sin of 1 minus n of x. This is what I will get. Okay, applying this, you can apply even the other one also you can apply. So what is that you get here? So I will start writing from here so that I will have more space. So 1 by pi, it is integral of 0 to pi. I will take this as x into sine of n plus 1 dx. And let me have it as a uniform. Instead of 1 minus n, I will write n minus 1. This minus will come, sine of minus theta is minus sine theta. So I will write this as, see, I will write this as integral of 0 to pi x into sine n minus 1 of x dx. So I hope that you understand why I write that. Because I am having here n by n plus 1, I want to have here also n first and then 1 first. Here you see that if I take this n minus n outside, it will be minus will come term outside, so it will be minus sine theta. So that is why I wrote it as minus here. So n minus 1 this. So you see that this is sine n minus 1 of x dx. Now you see that now you will apply the Bernoulli's method here. So 1 by pi into, I will write this as, see, it is, what is, see, this you call it as, see, sine of this one, no, you will write this as, see, it is like this, it is 0 to pi x into d of, here sine you must get means what, minus cos n plus 1 of x divided by n plus 1, and this is 0 to pi x into, again it is what, d of minus cos n minus 1 of x divided by n minus 1. I hope that you are able to understand what I do. Here you see that if you take the differential, see, I will write it here. If you take the differential of this d of minus cos nx n plus 1x, then differential of is cos is minus sine. So minus into minus will make it as plus. Sine of n plus 1x into n plus 1 divided by n plus 1, so you will get the same thing. Here again the same thing I am getting. So I will rewrite it. Now you take this as your u and v1. Here it is u and v1. Now apply Bernoulli's method. Are you able to understand how I do this? So this will be, I will use this space now here. So what is that I will get here now? So this will be equal to, now you tell me 1 by 1. So you see that this is 1 by pi into x into, what is that get? X into minus cos of 1 plus on x divided by 1 plus 1 minus, differentiation of x is 1 into minus is that, minus you put, and what is the integral of cos of n plus 1x? Integral of cos of n plus 1x. What is the integral? It is sine. It is integral of cos n plus 1x is sine. So it is minus sine. Minus is already there. So n plus 1 of x divided by n plus 1 whole square. And this must be raised to 0 to pi. Okay? This is for 0 to pi. In the same way, what will happen here? Put this minus sign, open a bracket. Same thing that you will write here. Minus cos n minus 1 of x divided by n minus 1 minus, again differentiation is 1, and here you see that minus sine n minus 1 of x divided by n minus 1, and this must be raised to 0 to pi limits and close the bracket like this. This 1 by pi is staying outside. So you see that here, so this is what I get. Now go slowly and do the problem, then only you will get the answer. So what is that you will get here now? Do this. So these are not required. Let me rub off this. I want more space now. So you see that 1 by pi, you apply the limit here, pi. So this will be minus pi into cos n plus 1 pi divided by n plus 1. Here you put pi in the place of this x. If you put pi, n plus n is taking the value 1, 2, 3, like that it takes the value. Whatever value that you are going to give, even 1 pi is 0, cos sin n pi is 0, sin 2 pi is 0, sin 3 pi is 0, sin n pi is equal to 0 for all values of n. So this will become 0. Okay, are you able to understand? So you see that, and if you apply the next limit, if you put 0, here x becomes 0, so 0 into anything is 0. And sin 0 is 0, so you are left only with this term. So for this you will get only this. Then minus, do the same, apply your logic now. You apply the ideas that you have gained in mathematics. So you see that when you put here, it will be pi again. It is minus cos of n minus 1 pi divided by n minus 1. Now I will apply the same idea here. So you see that whether it is minus n minus 1 or n plus 1, you see that sin n pi will always be equal to 0 for whatever be the value of n. So this will be 0. And if you apply 0 here, x is 0, so it will go off. And here it will be what? Sin 0 is 0. So this becomes 0 for all values. So don't worry about this. So you are left only with this. I hope that you are able to understand. So you see that this is, you will get this as, this is minus into minus is plus. So you will get this as 1 by pi. I will take this outside. So this is nothing but, it is pi into cos of 1 minus pi divided by n minus 1 minus, it is pi into cos of n plus 1 divided by n plus 1. So you are left with this. Now you see that this is pi will come out, pi by pi, and you see that this is cos n minus 1 pi. This is cos n minus 1 pi means what? You can write this as minus 1 to the power of n minus 1 divided by n minus 1. So you see that this is n minus 1 of pi. N minus 1 of pi. So you see that here the pi value will be what? So you can get the values of all these by taking. See, if it is a cos n pi, what is cos n pi? Cos n pi will be equal to minus 1 to the power of n. So what is cos n minus 1 of pi? It is equal to minus 1 to the power of n minus 1. So you see that this is cos of, and this is what? Minus, it is minus 1 to the power of n plus 1 divided by n plus 1. Okay, I hope that you are able to understand. So this is what you get here. So these two will go off, giving you what? So this is nothing but, see, minus 1 to the power of n minus 1 is the least. So divided by 1. Here you see that this is LCM is n minus 1 into n plus 1. Over this you have got what? This is n plus 1 minus. So when you take this minus 1 to the power of n minus 1 outside, you want here, see, minus 1 to the power of n minus 1 into, if you take this minus 1 whole square, you see that if you add minus 1 to the power of n minus 1 plus 2 will be equal to your this one. So this is nothing but what? It is minus 1 whole square. So this is what you get. So this is equal to minus 1 to the power of n minus 1 divided by n minus 1 into n plus 1, and within brackets it is n plus 1, and here you have got here what is that, here n minus 1, say n plus 1, here n minus 1. LCM is n plus 1 into n minus 1, so this is n plus 1 of that, this is n. So what is that you get here? Minus 1 whole square is 1, positive 1. So it is minus n plus 1. So this 2 will go off, giving you what? So you will get this to be, see, minus 1 to the power of n minus 1. It is n minus 1 into n plus 1 into, what is this? N plus 1. And what is this? 1 plus 1 is 2. So your 2 into minus n to the power of n minus 1. Okay, so you see that this is the value that I get here. So I have got the value of A0 and En. My problem is almost over. I can write the Fourier series. So you are done. You are done finding the Fourier series. Then we will come to this afterwards. I hope that. Now you see that we will have to discuss here. See here you are getting my n minus 1 and n plus 1. Now you see that this An will become 0 if we take n is equal to 1. So we have to discuss the cases when n is equal to 1 and n is not equal to 1. When, because n can take all values 1, 2, 3, 4, 5 like that. So if n is equal to 1, see the whole denominator becomes 0. So the whole term will become 0, but it is not so. We have to find out what could be the value when n is equal to 1 and when n is not equal to 1. So that also we will do. Okay. Now, so I will write here. So what do you get for this? An. So I will write here. So we have got the value of, it's fine. So you have got An is 2 into minus 1 to the power of n minus 1. It is n minus 1 into n plus 1. So these are all very, very important. And as I told you, because it is a cosine series, Bn is 0. So don't worry about that. Now let me start with the discussion on this. See what is the discussion that you have to make here. Now I'll write here. See, so one by one, slowly you will go, you will get the answer. So let me take An is equal to 2 into minus n to the power of n minus 1 into n plus 1. Now, case 1. When n is not equal to 1. So when n is not equal to 1, what is that you will get? When n is not equal to 1, you will retain the series as it is. That means what? An will be what? You should not take n is equal to 1. So the series will be An will be, because only when you put n is equal to 1, this will become 0. When n is not equal to 1, it can take, it can take other than 1, it can take any value, 2, 3, 4, like that. So about which we are not bothered. As long as it is taking this n is not equal to 1, this series will remain the same. So this An will be equal to 2 into minus 1 to the power of n minus 1 divided by n plus 1, here provided n is not equal to 1. Now case 2. When n is equal to 1, what will happen if you take n is equal to 1 here? So if you take n is equal to 1, what will happen here? So if you take n is equal to 1, here, see you cannot conclude from this. Here what I am telling you is that, here I will take up this, see, I will write here I will make a discussion in this case. See, what I will do here is that, see, we have got this An is equal to, I have got this, What is that I have got here? Pi and pi goes off. It is cos, we have got here cos n minus 1 pi divided by n minus 1 minus cos of n plus 1 pi divided by n plus 1. So you see that when n is, and 1 pi and pi goes off, no problem. So you see that when n is equal to, so when n is equal to 1, when n is equal to 1, see that this can go, that means what? This particular part can become 0, but the other part is 0, that means it is cos of 1 minus 1 of pi divided by 1 minus 1. This is 0, but it is cos of, when n is equal to 1, it is 2 pi divided by 2. 2 pi is always equal to 1, so this will be equal to minus half. Can you catch what I am telling you? So you see that here in the case, this is a special case. That means what? For n is equal to grade 2 and more. What is it? For n is equal to 2 and more, this will be good. So this is valid for what? N greater than 2. But for n, that means what? You should not take 2 or, that is greater than 2 or more. That means for all values n is equal to 2, 3, 4 like that. But for n is equal to 1, for n is equal to 0 we have got separately. Take it from me. A0 separately found. And but coming to this place, you see that where we are discussing when n is equal to n case, because this n minus 1 is coming at the bottom, it is giving us a trouble. So when n is equal to minus 1, this will become 0, but it cannot become 0 because an value has been found to be this much. We have found. From this only we have done all values and we have got this. So this is valid for what? All values. But for n is equal to 1. So when n is equal to 1, what will happen? That is my question. So asking, now coming to this, don't take this will mislead you. So take this, because from here only I have got this result. So go to this place and start the discussion. When n is equal to 1, you see that this will become 0, because this is, as I told you, 1 minus 1, this may be 0. See, n is equal to 1, this may be 0. This is 0, 1 minus 1 is 0. Whereas in this particular case, when n is equal to 1, cos 2 pi is 1 and cos 2 pi is 1. It is 2 pi is 1. So divided by 2, minus is there. So you see that minus half. So you see that here I will write this. See, what is that you will write here is, see, here you will write an is, see, I will write here an is equal to so much for n greater than or equal to 2 and a1 is equal to minus half. So I have found the value to be minus half. Am I correct or not? So you see that here if you put this one, no, this pi goes off, no problem. So you are getting this. So you are getting this 1 plus 1 means for 2 pi by 2. So this is the value. So what is that you will write here? So in this place you must write here n is greater than or equal to 2 and a1 is equal to minus half. So this is very important place. This is very important place. So you write like this. Now let me write the Fourier series now. Fourier series in terms of cosine. So I will start writing Fourier series in terms of cosine. So what is your f of x now? So f of x is equal to x sine nx is equal to, see what is here, a0 by 2 plus sigma of 1 to infinity of, it is an cos nx. So a0 by 2 is what? 2 by 2 plus, because a0 is 2 and plus what is my an? An is what? It is, see, a1 must be written. So I will write this as a1 plus 2 to infinity of an cos nx, because a1 is separately formed, because it will not give you, an will not give you. So a1 is separately formed. So this will be equal to 2 by 2 plus, it is minus half. A1 is, see here, it is minus half. So it is minus, when you put cos, see 1, it is, when you put n is equal to 1, it is cos x. Cos x plus, it is sigma 2 to infinity of, it is 2 into minus 1 to the power of n minus 1 divided by, it is n minus 1 into n plus 1 into cos nx. So this is your series. Now how will you expand this? So this is 1 minus half cos x plus, I'll write the full series here. Put n is equal, so it starts from 2. So if you put 2 minus 1 is 1. 2 into 1 is 2 plus 1 is 3. If you put 2 to the power of minus 1 is what? Take this 2 outside, don't worry about this, because 2 will be coming throughout. So if you put 2 minus 1 is 1, minus 1 raised to the power of minus 1 is minus 1, and it is cos 2x. Then plus, now you put n is equal to 3. Put n is equal to 3. So 3 minus 1 is 2. 3 plus 1 is 4. Then n minus 1, 3 minus 1 is 2. Minus 1 whole square is positive. So you see that you will get 1. And it is cos 3x. Okay? Plus, put, see here 2, 3, put n is equal to 4. If you put n is equal to 4, 4 minus 1 is 3. 4 plus 1 is 5. Then 4 minus 1 is 3. Minus 1 to the power of 3 is minus 1 into cos 4x. It goes on like this. This is the series. Now we have to get this one. See, I have to get this. Now you see that this is the series. Okay, let me take this as my series. Now let me find out. Let us prove this. So this is my Fourier series. This is my Fourier series. This is my Fourier series. Now let me find out. Let us prove this. Let us prove that. Let us prove that. Let us prove this one. Let us prove one. Now, see, in 2, this is your 2. In 2, take x is equal to pi by 2. Because I want here on this side pi by 4, something like this. So you take take x is equal to pi by 2 in 2. So what is that you will get here now? So x is equal to, so you see that f of pi by 2 is equal to pi by 2 into sine pi by 2 is equal to 1 minus half cos pi by 2 minus 2 into 1 by 3 into cos 2 into pi by 2 minus 1 by 2 into 4 into cos of 3 into pi by 2 plus 1 by 3 into 5 into cos of 4 into pi by 2 minus dot like that it goes on. Now you see that this one is 0. So this is sine pi by 2 is 1. So this gives f of pi by 2. This is pi by 2 is equal to 1 minus sine 90 is 0. So this goes off. Minus 2 into. See, this is 2 and 2 will go off. Cos pi is minus 1. So it is minus 1 divided by 1 into 3 minus 1 by 2 into 4. So you see that this is cos 3 pi by 2. Cos multiple of cos n pi by 2 is always equal to 0. See, cos n into pi by 2 is equal to 0 for all n. Even whether it is a positive n or negative n, this is going to be 0. So you see that this this will be cos 3 pi by 2 is equal to 0. So this value is 0. Then this will be what? It will be, so this is into 0, I will write. Then plus 1 by 3 into 5. This is 2 pi. Cos 2 pi is equal to 1. I have told you many times. So into 1. Then next one will be what? It will be, let us take it to be minus. So you see that what is that you will get here? 1 into, this is when you give n is equal to 3, 4 you will give. If you give n is equal to 5, you will get what? You would have got this. See, I will write one more term here so that you will understand. So it is equal to what? It is 1 by, it is because of 4, it is 5 into 6 into cos, you are giving 5 into pi by 2. It is plus. I will do only one. So you see that here, if you give n is equal to, here it is give 5. 5 minus 1 is 4. See here it is 5 minus 1 is 4 into 5 plus 1 is 6. 5 minus 1 is 4, 5 plus 1 is 6 into cos of this one. Don't worry about this. Cos into 5 pi by 2. I told you cos n pi by 2 is equal to 0 for all. So this will become 0. And what will be the next one? I will just write for your this thing. It will be plus. If you give 5, it is 6. No. 6 into 5. Then 6 by 7 into cos 6 pi by 2. So you see that what is that you will get here now? So you will get 5 pi by 2 is 0. Then if you get 3 pi, that means what is that you will get here? You will get 6 by 2. So this will be equal to your 1 by 5 into 7 into cos 3 pi. And you see that what is the value of cos 3 pi? Cos pi is minus 1. Cos 2 pi is plus 1. Cos 3 pi is minus 1. So you see that your next term will be here. It will be what? It will be like this. So what I will explain this. So you see that I have done here much of application. Let me not confuse you more. So wherever this pi by 2 comes, it is 0. And when you get odd multiple of pi, it is minus 1. When you get even multiple of pi, it is plus 1. For example, you see that here it is even multiple. Then the next one will be odd multiple. That will be minus 1. So this is minus. Then next is plus. Next is minus. So you see that it will be even multiple of pi by 2 pi, odd multiple of pi, even multiple of pi, like that it will go, so that every term will be alternately minus plus, minus plus. So you started with C, here it is 0, 2, and this is what you get. So I have written here. See, pi by 2 is equal to, I have written this 1, and this is 0, don't worry about this, minus 2 into, this is pi means minus, this is 0, then this is plus, and next will be what? Minus. It will be minus 1 divided by what? So this is gone. 1 into 3, 3 into 5, 5 into 7, and it is like this. And what will be the next one? 1 divided by 7 into 9. So the series will be going on like this. So this is what you will get. So what is that you get here now? So this will be, I'll rewrite this. I'll rewrite this. So what is that you will get here is pi by 2 is equal to 1 minus, I'll write this again. So it will be what? Minus 1 by 1 into 3. Next is number 1 into 5. Minus 1 by 5 into 7. Plus 1 by 7 into 9. Minus 1 by 9. Like that it goes on like this. So this will be equal to what? You will get this to be, what is that you will get here? Take this minus sign outside. So it is 1 plus 2 into 1 by 1 into 3 plus 1 minus, here it is minus 3 into 5 plus 1 by 5 into 7 minus dot 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 dot. It goes to infinite series. So this is equal to, so what is that you will get here now? So what is that you will get here? So therefore it is, so you bring this one to the other side. You bring this one minus you have taken. So you bring this to the other side. So pi by 2 minus 1 is equal to, simply it is 2 into 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 minus dot 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 up to infinity. Now let me simplify further. How does he want the answer? So this is that is 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 minus dot 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 is equal to half into, within brackets it is pi by 2 divided by 2. So what is that you will get ultimately? What is the answer that you will get? So this implies 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 minus dot 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 up to infinity. Take this half inside. So minus 1 2 divided by 4. This is your answer. So that is what you are asked to prove, and this has been proved. So this is I have taken a different type of problem, and still I will do heat wave equation. You have got wave equation and heat equation. I will do problems in wave equation, heat equation.